Hello, my name is Michael Goro, and I will quickly tell you how to do one of these online labs. I developed a lot of videos for EEE 120, the Digital Design Fundamentals course. So let's get going on a very simple circuit, an inverter gate, and let's test if it actually works. So for that, I take my breadboard, and I have already put a chip here, a 74F04, which is an inverter chip. And I've put the header rows, as well as a single header here. The single header connects to pin number 14 on the chip, and the header rows connect to pins 1 through 7. So once you've built your circuit, you need to connect your analog discovery kit. And again, your analog discovery kit consists of the main unit, which is this green one if it's from Digilent, blue if it's from National Instruments directly, or the analog discovery kit 1, which is the black box. Inside of the analog discovery kit, you have a micro USB cable, and you have these breakout wires. They are actually color-coded, so it makes it very easy to plug by color code. What you need to do now is connect the analog discovery to your computer, and you should have the waveforms software already installed. You can either use the classic waveforms or the waveforms 3 or waveforms 2015, how it is called. Waveforms 2015 runs on all platforms, Windows, macOS, and Linux. Digilent has videos, has a lot of online resources how to get waveforms going. So once you've installed the software, once you've connected the analog discovery, again, it just takes the USB cable. There is an extra power supply which we will not be using. In fact, there is no lab in our curriculum that will need the extra power supply. So once you start waveforms, you should see the Discovery 2 being detected. It will report it with a serial number and status OK. Now we have different instruments on the left: scope, wave generator, supplies. So supplies we will eventually need. So I click on that, and I see master enable is off. I don't want to switch it on just yet. Positive supply ready, negative supply ready. I don't need a negative supply for this integrated circuit, so I might as well switch it off. Positive supply is ready, but I need 5 volts. So I need to increase the voltage to 5. If you have an analog discovery 1, 5 volt is the default. There is no selection of the output voltage. Once you're fine with that, you can start connecting the wire harness. And if you want to power the chip, you actually need to connect the ground, which is one of the black wires, and the V+, which is the red wire. And so you see it in the camera, the bottom row starts with pin number 1 and goes to pin number 7. Then it wraps around and goes all the way to pin number 14. Pin number 14 is the positive voltage supply. So we'll connect the red wire to that one. Pin number 7 is the ground. I will connect my black wire to that pin. So what is left? Well, we need an input and we need an output to test our logic chip. And for that, I will use the digital I/O lines, in this case 0 and 8. 0 is a pink wire, 8 is a pink and white wire, and I will configure 0 to be a digital output, which will go into an input of my chip. And an input in this case is pin number 1. Again, in an actual lab, you will get lab instructions on how to wire the chips and how to test them. Eventually, you want to test the output, and for that, I use the input number 8. And an output of the chip is pin number 2. So I'm plugging that into the next one, which is pin number 2. Now I need to go back to my software, and before I turn on the power supply, I want to go to static I/O. Right now, everything is flashing randomly. Well, that is because there is no input to all of these lines except for 8. However, I don't want these to be inputs to my system. I want this to be an output, so I need to go to bit I/O, switch, and I use push-pull. Now all I'm interested in is switch number 0 and LED number 8. But before I do anything here, I need to switch on my power. So I'll go back to supplies and do the master enable is on. The status is still okay, so I do not have a current overload. Again, the maximum current is 700 milliamps per output per channel, which I will never exceed. So right now, 8 is on, so it's statically lit up. Eventually, I know this is a logic 1. If I toggle the switch now by grabbing it with the mouse and shifting it, I turn the output on of my analog discovery, and my input will turn off. I verified that this particular input on the inverter is working. All I have to do is write a check mark in my lab notebook and eventually take out my cell phone, take a snapshot of the circuit that I built. That serves as a quote-unquote attendance stamp, put it into your lab report, and submit it electronically. Other labs work very similar to this, and again, just look at the lab instructions and they should be pretty clear. Thanks for watching.